Fun with algebra. Blow this up a little more. So like terms, it's like inches versus square inches. You can't add those things together. So 3x plus 4, you can't simplify it because we don't know what x is. So the best you can do is look for other things with an x and just deal with those. So 3x's, take away 5x's, leaves me with a loss of 2x's. So just think about the x as an object. And then the 4 is like the 6 because they don't have x's. Plus 4 plus 6, that's going to be a plus 10 altogether. So part A should clean up to be that. In part B here, it's not just the x that's multiplied by 3, it's the whole subtraction. So that is what we call the distributive property. So that's going to, another way to write this would be a 3x minus 3 times 2, which would be 6. That's called distributing. Next part, we get a double distribute to do. So I'm just going to do them one at a time. The 5 is being multiplied by both pieces in the parentheses, and then the parentheses ends that. So 5 times 2 is 10 x's, minus 5 times 3 would be 15. The next part's a little bit tricky because in algebra, we consider a subtraction to be adding a negative. So the point there is the 4 and the negative have to get moved over. So that's going to be a negative 4 times 3, which is negative 12, and the x just hangs on. And then that's a negative 4 times a positive 2, which is a negative 8. So again, importance there is that subtraction moves into the distribution with the 4. Do we have like terms here? We got a couple. The 10 and the 12 are like because they both have x's. So I have 10 x's. I lose 12 x's. That's a net loss of 2 x's. And then we've got the negative 15 minus 8. So we lost 15, then we lost 8. That's a loss of 23, I think. Sounds right. So that would be the, what's that? It's just a straight minus. Yeah, it's a negative 15 combined with a negative 8. Yeah, and we could reorder these. So if some people like having more steps, so an intermediate step I might write here, if that's not quite making sense, is I can reorder these and say this is 10x minus 12x minus 15 minus 8. And then I do the ones that are like. So I get, for a simplified version of that, as negative 2x minus 23. All right. These are a little bit different. Here we're going to evaluate formulas. And some of these we could use a calculator. Some of these we should use a calculator for. So evaluating expressions is just plugging in the given number. So here they want us to evaluate 3x when x is 6. So I'm just going to take 3 times 6 for 18. The next one, I want to evaluate 4x minus 2 when x is negative 5. And often when we plug stuff in, we use parentheses to be safe. So I would write 4 parentheses negative 5 minus 2. Order of operations, we got to do multiplication first. 4 times negative 5 is negative 20. Then minus 2. So I lost 20, then I lost 2. Altogether, I'm down 22. Here, when we plug in a number, especially a negative number or a fraction, parentheses are a good idea. So I would write 3 times parentheses, negative 2, close parentheses, then square it. Then we've got a minus 5, and instead of an x, we've got a parentheses with a negative 2 in it, because x is negative 2. Close parentheses plus 3. Calculator's not a bad thing. I'm going to try doing it without. Order of operations, I get a square. There's nothing to do inside the parentheses. It's just a -2. So I move to the square next. -2 times -2 would be a +4 times 3. That's essentially -5 times -2. Negative times a negative is a positive, so that'd be +10. And then we still have the +3 hanging out. And I'm just going to block that off for a moment. I'll do that one later. 3 times 4, I got to do multiplication before addition, so that'd be 12. Then I can do +10, and then I can do +3. So 12 plus 10 is 22, plus 3, it looks like this should be 25. And this one was complicated enough that I really think we should do this on a calculator. So I'm going to whip out Desmos for this one just to double check. Couple ways to do this on Desmos. You can use the previous answer button, kind of like they have X in there. So I could do something like type -2, and then I can type the expression they gave me, 3x squared minus 5x plus 3, but instead of an X, just use the answer button. And then I don't have to worry about parentheses. So 3 times the previous answer squared minus 5 times the previous answer, right, which I entered already. And then I forgot what the next part was, plus 3. Otherwise, you got to use parentheses. So the calculator believes it's 25. So otherwise, I have to do 3 times parentheses, -2, close parentheses, then do the power, minus 5 times parentheses, -2, close parentheses, plus 3. Looks like we're doing all right. All right, part D. Evaluate LW, no symbol in algebra means times. So I want to take the 5 times the 4, which is 20. Pretty straightforward on that one. And part E, which I erased for a moment, we want to evaluate pi times r squared if r equals 6. So that's just simply pi times 6 squared. Parentheses are optional here because it's not a negative or a fraction. But again, negatives and fractions, you really should use parentheses. Otherwise, the calculator will not behave right. But they don't hurt here. All right, 6 times 6, 36. But pi, I need the calculator for most days. So I'm just going to retype it the way it was given. Pi times 6 squared. According to my calculator, and let's just go to the nearest tenth for the hell of it. So I would say that'd be 113.1. So approximately 113.1 to the nearest tenth. All right, more fun with algebra. So the equation we came up with before was, place I can write. New page. We want to calculate the tax. They're saying call it T. So we're going to write T equals. And the way we did that based on line 2 of our tax table was starting with 1,815, we're going to add on 15% of the excess. So we're just going to rewrite how we did that. Somewhere, there we go. Oops, pages are out of order, fix that later. So to get the tax of somebody in this bracket, they automatically have to pay $1,815. There we go. And then they have to pay 15%. We're going to enter that as a decimal, 15 hundredths, times parentheses, whatever their taxable income was, we're just going to call that an X minus, so we want to know the difference between that and the 18,150. That's the formula we used before, but instead of an X, we had 72,700. Next, simplify the formula using distribution and combining like terms. So the tricks we just learned about algebra, we're going to apply here. And the distribution that needs to happen here is to multiply that 0.15 into this here. So that's going to be, we still have the 1,815 chilling out, plus 0.15 times X. And then we have to figure out what is 0.15 times 1,800, sorry, 18,150. So before I write that down, I'm going to simplify it on my calculator. What happens when I multiply these two numbers together? So 0.15 times 18,150, I get 2,722.50. Anyone else back me up on that?
Yeah.
Okay, thank you. 27225. As far as like terms go, these two terms don't have an X, so I can combine those. So I want to ask my calculator, what is 1,815 minus the number we just calculated? All right, so $1,815 minus my previous answer. My calculator says it's negative 907.50. Negative 907.5. I think I got that right. Looks right. So what we now have is, again, we combined this number with that number. I'm going to write it over here on the right. That was the negative 907.5. And then the 0.15x just carries down. So the point is, this should be another way to calculate this couple's tax. I'm going to do a little check to see if that actually works, to see if we get the same number we got before. So I'm just going to go to my calculator. I'm going to plug in these, what was it, 72,700. That was their original taxable income, and see if it makes sense. So we should, the formula now says take 15%, 0.15 of whatever the taxable income is. This couple had 72,700, and then subtract the 907.5. And that should give us our original tax we got for them, which is the 997.50. So that new formula does work. Which one's better? They're both good. This one's easier to type into a spreadsheet or a calculator, but this one more accurately describes what happened. There's just two different ways to get the same answer. All right, almost done. Let's see, that was 8, right? Okay, 9. Assume only that we're interested in couples who file the 1040EZ and only have wage income. Write an equation that will take the wage income and compute the tax they owe. Okay, so couples wage income. All right, we got to go back and review the form to see what that means. So way back, I think it was page 1. So the wage income, that was line 1 here. And their wage income was the 93,000. So assuming they had no other income, how did we do that? Well, did we plug 93,000 into our formula? No, we plugged the 72,000. Where did we get the 72,000? We subtracted the 2,300. That is the standard deduction for couples. So we just need to add that to our formula. No big deal. So we're going to amend this formula right here for question 9. Oop, that line did not go well. Again. So this is question number 9. And what did they say to call it? What was the variable they wanted us to use? W for wage income. Okay, so we're going to use a W. So in place of the X, what we're going to do is we're going to rewrite big T equals 0.15, and instead of an X, we're going to put a big parentheses there for a moment, and then put the minus 907.5. To get that value for the X, the taxable income, we had to take the wage income and subtract the standard deduction. So in the parentheses is going to be a W minus the couples deduction, which was 20,300. So again, we're replacing X, the taxable income, which how did we arrive at that? We took their wage income, subtracted 20,300, then we can do all this other stuff. So this is the answer for 9A. And I believe 9B says clean that up a little bit with a little algebra. Let me just double check, make sure I got the instructions right. Simplify the formula. Okay, we got this. So again, that's the formula for 9A. We're just replacing the X with parentheses W minus 20,300. To clean that up, we got to distribute that 0.15. I'm actually going to write that down this time. So I'm going to have 0.15 W minus, I got to figure out what is 15% of 20,300. And then I have to subtract the $907.50. So next, whip out a calculator and do this right here. What is that on your calculator? All right. Anybody got a suggestion? I'm getting almost negative 4,000. There's something wrong. Okay. So important thing here is don't forget the negative belongs to the product here. So it should be a negative number. So the calculation should look like this. Negative 15% times the 20,300, then minus the 907.5 to get the right value there. Yeah, that's what it is. Okay. Yeah. And again, common things that get me in algebra is I'm missing a negative somewhere. Because that's part of the tax they owe, so it comes off. So I'm getting negative 3,952.5. 3,952.5. Did you do the minus 900 also?
Yeah.
Oh.
You minus the,
Did I do something wrong?
What you need to do is actually add it to the minus.
Okay, so the calculation should be negative 15% times 20,300. Okay, yeah, and then minus the 9. Yeah, because these are coming off. It's money that's owed. So that, oops. My formula finally for this one is capital T equals 0.15 W minus 3,952.5. And what this formula is designed for is for somebody to just plug in their wage income. So if I plug in the $93,000 here, the original wage income, out should pop the amount of tax they owe. I'm going to double check, make sure it works. So I want to take 15% of 0.15, their original wage income, 93,000, and then subtract that number above, 3952.5, and out pops the tax we already know about, $9,907, sorry, $9,997.50. Ta-da! You're done. Good job, everybody.
Almost